Hello everyone, welcome to the class. Today I'm going to show you how to use these bit operators to work on the bits like a sequence for some applications. For example, how to extract specific bit from the data or how to update a data, how to update numbers in this like bit sequence. Okay, so let's start. So the first application is extracting. Sometimes we want to get some range of bit from your sequence of binary. So for example, this one, we have a 1 byte data, which has bits B7 to B0. So you can imagine that it can be a number 1001, 0110. Everything is bit, right? So assume for some application, you want to get specific bit from the data or a couple specific bit from the data. For example, I want to get these three. How to get these three? So actually, the method is not so difficult. It's not so difficult. All you need to do is use the left shift and right shift, and you can do the same thing. So for example, if I do this data, I want to get these three. Which bit we want to make them to become 0. So actually, everything here we don't care, right? Everything here we don't care. So if we want to get like what's the value, what's the decimal value of these 3 bits, we first of all we can do is that we just do some shift, do the left shift. So if we do a left shift, each left shift we move the data, go to the left. We add one more 0 after it, and we get rid of each bit on the top, right? If it's a byte. If you use the data, for example, character to store this data, because character only have a 8 bit, the 1 byte. So every time you do the left shift, it will get rid of 1 bit because of it's out of range. So if we do this 4 times, we can get rid of all of it here and get 4 zeros after the end, right? In this case, we already remove this 4 bit. So when we do the right shift after this, we don't need to worry about this data. Okay, so after we do a left shift, let's say 4, what we will get is we got B3, B2, B1, B0, and the 40 here, right? So the next thing is that this is the only 3 bit we want to count, we want to keep, and we want to get the decimal value of these 3 bit. So the next step, we need to get rid of everything here. How to get rid of everything here? Do a right shift, right? Do a right shift. But here's something you need to pay attention. When we do a right shift, it can apply a logic shift or arithmetic shift, right? So it depends on what. If it's a side character, then when you do the right shift, it will put 1. It will put 1 before it. Assume B3 is 1. If B3 is 0, you don't need to worry. But if B3 is 1, then it will keep update each 1, right? So this is not a good idea. So before you do this right shift, you need to make sure it's on-site. You need to make sure it's on-site, because when you do it on-site, then you will run the logical shift. Okay, so we want to do is we want to shift 5 here with logic shift. This is a key. Okay, so pay attention on this part. So when you do a right shift with this 5 logic shift, you will get rid of each number here and put 0 in front of it. So after you got this, you will get 0, 0, 0, 0, 0, B3, B2, and B1. So in this case, what you need to do is do the left shift, then do the right shift, then you solve the problem. And how many shifting you want to do depends on the position of your bit. So if we want to work on the B3, we need to do the shift 4. If we want to do the B2, we want to shift to 5. If we want to do the B5, we want to shift to 2, right? So there's some pattern here. And you just need to kind of like use this pattern to do this shift. You can easily find how many like left shift you want to do. And same thing happened in a right shift. In the slides, we give you the ideas how to generalize these patterns, okay? Okay, let's see the second example. So sometimes we can use extracting with mask to extract what we want. What's the mask means? What's the extracting with mask? Imagine that you have a sequence of data here. You want to extract B1 to B3. So actually you don't, in this case, you can use a left shift and right shift, right? But you can also use AND. You AND 1, 1, 1, 0, 0, 0, 0, 0. Then you will get B3, B2, and B1. Then you do right shift 1, then you just got everything. So in this case, you don't do the left shift to get rid of B7 to B4. You just do 1, 1, 1 and 1, 1, 1. So this 1, 1, 1 we call mask. So we wear the mask. So like a hide, like try to get like which one we want to have or which one we don't want to have. So this is the idea of mask. So how to get the mask in this example? In this example, if we want to use mask, you can look at, if we want to extract 3 bit, we need 1, 1, 1, 3, 1, right? How to get the 3, 1? A very easy way to get 3, 1 is you do the 1, 0, 0, 0, minus 1, then you get 3, 1. So how to get 1, 0, 0, 0? It's definitely easier. You just do 1 shift 3 because you want to get 3 bit, right? So you shift 3, you got 1, 0, 0, 0, then you minus 1, then you got this 1, 1, 1. Okay? So actually in general, what you need to do, how many bit? If you want to extract n bit, shift 1 shift n bit, then minus 1, you got you just got the data. So in this 1, 1, 1, because you want to put it in the right place, right? So you probably need to shift it again to shift it to the right place. Or you can also do something like if you have a mask 1, 1, 1, how to generate 1, 1 again? 1 shift 3 minus 1, it become 1, 1, 1. You can also do 1, 1, 1. Then you do the shift of the data. So assume this data is x. You just say x shift 1 because you want to get rid of the B0, right? If you want to get the B0, you need to run this. Then after you do this, you enter this data. Then you can also do the mask. So the idea of mask is that you try to get some bits always be 1. Then if you use the 1 and another data, then it will only keep the bits you want to in a range with your mask. And everything out of your mask, it will disappear. In another example, if you don't want this 3 bit, you want to, for example, I want to get all the bits except this one. If I want to get everything here, from here to here, I want to put everything here as 0. So how can I do? I can use the same way, right? So I have a 1 bit, 1 shift 3 bit, then minus 1. This is mask. So this mask is 1, 1, 1. Right now I shift 1. So I put it to the right place. So which means it's become 1, 0. So it will become the number of 1, 1, 1, 1, 0, 0, 0, right? Then I do AND. But before I do the AND, I do reverse. So if I do a reverse and the reverse this 1, it will become 1, 1, 1, 1, 0, 0, 0, 1. So I AND this data, I will get everything from B7 to B4 and also B0. And everything B3, B2, B1, because you AND to 0, it will just become 0. Okay, so this is another way to do the extracting. So I want to extract something not in a range. Then I use this way, use the mask. So how to generate the mask? The key is how many bits you want to get. Then you use a number one, shift the how many bits you have, then minus one. Then you can get how many one you have for the mask. So how many bits you want to do this mask? You can just use this way. It's a very smart and easy way to generate the mask. Okay, so in this case, if we know how to extract, how about if we want to specifically update some data? For example, we want to update the data from B3 to B1 to a data like, I don't know, C2, C1, C0, other for other bit. So I have a sequence of data in other place, and I want to do this. So it's not so difficult for this one if you understand how to use a mask. First of all, we do a mask. We want to get rid of everything here and here. We want to get everything here and here. We want to get rid of everything in this range because these 3 bits will be replaced, right? So what we can do is, first of all, we do the 1 shift 3. We shift the 3, then minus 1. We got mask, right? The mask is just 1, 1, 1. So we still need to do the shift 1 to put it in the right place. So this is our mask. Then if the data, this data is called X, we just do what? We do the X and or mask. Then we will get the data from B7 to B4 and B0. We get rid of everything in B3, B2, B1. So in this case, it will give us B7, B6, B5, B4, and B0. And everything here is 0. Okay. Next step, if we want to update, what we can do to update? We need to get these three bytes, right? So if we have these 3 bits, I don't know how to get this 3 bit. Assume this is a number. Let's say Y. Assume we have a Y number for this one. This Y equal to C7 to C0. And we want to get C2, C1, C0. I don't want C7 to C5. Assume. If this is the case, what we can do is we do the Y, and also we try to mask. We try to mask this data by the 3 bit, right? So how to generate another mask for this one? We need 3 bits from C0 to C2. So in this case, we also need to do the 1 shift 3, but we don't need to do another shift because it's from C2 to C0. If we change it to a different bit, then you need to do another shift. But this is a new mask, right? So if we do this new mask, we just add it, then we will get C 0, 0, 0, 0, 0, C2, C1, C0, right? So this is what we got. So we use mask, we can get rid of the data a bit from our original data. We can also save the bit from the new data. Then after we do this multiplication like updated, then the remaining part for this one is how to combine these 2 data, right? And it's not so difficult because you can shift 1, then do the AND. The OR, because you want to combine these two bits together, right? So you just do the OR here. After you shift 1, this data will become C0, C1, C2 with 0, right? So when you do an OR, it will OR everything here, everything here, everything here, and everything here. It will all together. So this is how we update the bit. So in this case, what you should do is you just do the X and mask here. Then this is Y with its mask. Then use OR. And you can generate it. So the X here, Y here, usually you can treat them as an integer, right? So they are just integer. A sequence of byte, sequence of bit, they are character or integer. Actually, in this case, it's character because only for a bit, 1 byte, right? So you can do something like we just, you don't need to convert the x to the binary. You just use the for example, x is 45. Then use the 45 and the mask. Then or the y, I don't know what's the y. Maybe it's let's give a number 7, and this mask shifting another mask, the second mask. You just do this, then combine together, and you can do the updating on 45 with some bit in 7. This is the idea. Okay, so this is third application to use these bit operators to work on this kind of bit shipment, bit like manipulation, and it's really easy to use. You don't need to convert the data from your character or integer to a binary. You can just use this bit operator to on this data, on this character or integer, because the character integer, they are just one way to represent the data, right? So every bit stored in this data, you don't need to convert it to a binary. You just run the binary operators, these bit operators on this data, and you can easily do the updated or extracting or masking this stuff on these data. Okay, so this is for today. We show you 3 examples how to extract the bit, how to do the mask, use a mask to like extract the bit or extract like some other range of bit, get rid of a bit from the data. We also show you how to use updated, use this mask generated from the second example. You can use this mask to manipulate 2 different data, then update each data, then combine these together, so you can do the updating on the original one. So I hope you got the idea today. I hope you like these videos. See you next time. The bit operators is interesting.